In this tutorial, we will prepare a complete Codegeist contributor workspace on Ubuntu, then build the application and run its real test suite. The supported path has 4 parts. Clone the public repository with its submodules, open the checked-in Devcontainer, build through the project task file, and verify the result with the project tests. This recording uses 3 environments. The Linux host owns the NVIDIA GPU and Ollama, and Ubuntu VM runs Visual Studio Code and Docker. The Devcontainer supplies the toolchain. QEMU networking connects the guest to Ollama without GPU pass-through. Before cloning anything, verify the prepared development system. This guest runs Ubuntu 24.04 with Git, Docker Engine, Docker Compose, and writable KVM access. The final request confirms that Ollama version 0.32.1 is reachable at 10.0.2.2, port 11434. Clone the canonical GitHub repository with recurse submodules enabled. That flag matters because Codegeist pins shared workspace components and reference projects as part of the contributor checkout. The transfer shown here is real. Git downloads the main repository, initializes each registered submodule, and checks out the exact commit selected by the parent repository. Only the middle of that transfer is shortened in this edit. When the clone finishes, Git reports the pinned commit for every recursive submodule. The checkout is on the public main branch at commit 51 at F3EC with no local modifications. This gives the rest of the tutorial a precise and reproducible source state. A few paths provide the fastest orientation. The Java application lives below App, Codegeist, CLI. Behavioral and platform tests are under Scripts, Tests. Contributor documentation starts in Docs, Developer. The root task file is the normal command entry point. .devcontainer defines the supported toolchain, while .opencode contains repository local agent workflows. .codegeist is reserved for ignored machine local state. The root README summarizes the project vision and points to the broader documentation. Use the repository-defined environment instead of assembling a similar toolchain by hand. It keeps Java, Graal VM, Docker, task, and tests aligned with maintainers and continuous integration. Open the Visual Studio Code command palette and choose Devcontainers. Reopen in Container. Visual Studio Code now builds the checked-in workspace image and reconnects this repository inside it. The first build is intentionally real and took about 11 minutes. This edit shortens the wait, not the setup or its result. During that first start, Visual Studio Code builds or downloads the required images and extensions. The container initialization prepares repository state, and the post-start entry point brings up Docker and Docker plus the services expected by development commands. A later start can reuse cached layers and is normally much faster. The important completion signal is shown here. Initialization and the post-start command both finish, and the editor reports that it is connected to the Codegeist Devcontainer. The workspace contains Java 25 on Graal VM, native image, Maven, task, PowerShell, and an isolated Docker daemon. KVM remains available for Smoke workflows, while Ollama runs on the Linux host. Now verify the toolchain from a shell inside the container. Java reports Graal VM Community Edition 25, and native image comes from the same distribution. Maven, task, and PowerShell are already on the path. Docker responds from the container's own daemon, which is why its initial container list is empty. Finally, the curl request reaches the external Ollama API through the QEMU host address and returns version 0.32.1. No NVIDIA runtime or Ollama installation is required inside this development container. Use the repository task file for development commands. Task CLI run builds the Java module, then forwards the version argument to the application. The first invocation scans the Maven projects, copies resources, and compiles the Codegeist module. This is the same checked-in build path contributors use, rather than a separate tutorial shortcut. Maven completes successfully, and task launches the generated Codegeist jar with the version option. 0.1.0 snapshot is the Maven development revision on this commit. It is expected in a source checkout and does not mean that the wrong public release was cloned. For this recording, the test task receives the prepared host Ollama URL and the small Llama 3.2, 1 billion parameter model. Run task CLI test from the repository root. The task validates the external API and selected model, then starts the actual Maven test workflow. It does not create, replace, or modify an Ollama container inside the Devcontainer. The final result is fully visible. 198 tests ran, with 0 failures and 0 errors. 6 environment-conditional tests were skipped, and Maven reports build success. The short time shown here benefits from dependencies and compiled classes already prepared by the preceding build, but every selected test still ran through the real project command. Finish by checking the repository itself. Git status produces no changes, so the script prints working tree clean. The short commit identifier is still 51F3EC, matching the source used throughout the recording. Open Docs, Developer, README for the maintained entry points to architecture, testing, specifications, and release procedures. Read those guides before choosing your first change, because they document the constraints that individual source files cannot explain alone. Your Ubuntu contributor workspace is ready. Visit Codegeist AI, browse the source on GitHub, and use the developer documentation to plan and verify your contribution. Codegeist is open source, and contributions are welcome.